Hello everyone, welcome to the channel. So in this video, I'm going to show you how to download and visualize the GRACE Tellus monthly mass grid, the land dataset using Earth Engine. Now let me explain about this dataset here. So the GRACE is a gravity recovery and climate experiment mission. So GRACE mission was a joint space project between NASA and German Aerospace Center designed to study the Earth's gravity field and how it changes over time. One of the key products generated by GRACE mission is a monthly mass grid, including those specifically focused on land. The changes in the distribution of the mass on or near the Earth's surface, such as the movement of water and ice, influence the gravitational pull experienced by the satellite. By detecting these changes in gravity, the scientists could infer the information about the movement of the mass on the Earth. So the monthly mass grid for land specifically refers to the data that captures a variation in the distribution of land-based mass over the time. This can include changes in water storage such as groundwater depletion, snow and ice accumulation or melting, and other terrestrial processes affecting the mass distribution. So the researchers use this data to study a variety of earth science phenomena, including the hydrology, climate changes, natural disaster, sea level rises, and geophysics. So monthly mass grid provides a spatial and temporal record of how the distribution of the mass on the Earth changes from month to month. So this data is valuable for understanding the dynamics of Earth system and for improving our ability to model and predict the environmental changes. So this is our GRACE monthly mass grid land. So data availability is from 2002 to 2017. And the dataset provider is NASA Jet Propulsion Laboratory. So using this specific code, you can access this particular set of code using our Earth Engine code editor. So a few description about this data here. So this particular data provides our monthly gravitational anomaly. Now let us visualize the bands available here. So there is 3 different bands have been available in this set of particular data here. So you can go through this data. The link will be given in the description. You can check out that. Now let me get back to our Earth Engine here. So now to import this image into our Earth Engine, we define a variable called image collection equals to image collection NASA GRACE mass grid lambda. So this specific set of code will insert our. So next is I define my study area. So I defined geometry equals to feature collection. So this specific shapefile has been inserted into our Earth Engine. I've uploaded into our Earth Engine. So I can just access to go to asset section. In that you can able to visualize this particular option called study area. So to import your shapefile into this particular code editor, you have to click this option called import into scripts. So once you did that, your shapefile gets inserted into our Earth Engine. So just change the name of this variable from table to geometry and you're ready to use. And how to upload a shapefile in Earth Engine link will be given in the description. Check out that video. Now to select a particular band, so we are using this LWE thickness CSR. So we are using this particular band from our GRACE dataset. So to select this particular dataset, we define a variable dataset equals to image collection dot select LWE thickness CSR. And to visualize the particular set of results for this particular band we are using, so you can just visualize it. We are using print dataset dot size function. So next, filtering data by a date. So we are using variable date filter equals to dataset dot filter date. So we are specifically filtering from 2005 January 1 to 2006 January 1. And to visualize the result of that, we can just enter this code called print date filter dot size function. So next, to calculating the mean and clipping based on our study area. So geometry here refers to the specific study area. Suppose you want to specifically study the gravity anomaly of your study region, so you can insert your shapefile. So this is our geometry shapefile. So we define as a variable mean GRACE equals to date filter dot reducer dot mean. Next, we defined a variable called study area to specifically clip our GRACE data based on our study area geometry, referring to this particular one. So variable data study area equals to mean GRACE dot clip geometry. So next, to define our visualization parameter, so we defined a variable called style equals to we set a minimum value of -25 and set to a maximum value of 25. So the color palettes we are using yellow, green, orange and red. So the red indicates the highest anomaly and the yellow indicates the least anomaly. So to add this layer into our Earth engine, we define map.addLayer, study area, style. So style refers to our visualization parameter. And the style refers to a visualization parameter, and we're going to output the layer name as study area. And next we're going to add our grace data for entire globe. For that we defined map.addLayer, mean grace, and style refers to a visualization parameter, and output the layer name as a grace. So it is a global, we're going to visualize a global grace data for our for entire globe, only for land. So next once you defined your study area, so suppose if you want to clip only this portion of the study region, that is to download the grace data for only this portion of the study region, so you can just export that to a Google Drive. So for that we can export.image.to-drive, and image here will be represented as a study area. So this is our study area, and description is grace, and spatial resolution will be 30, and the region is our study area. So once you did that, you can just navigate to this option called run and click this option called run. And once you did that, we're going to visualize our data here. Let me zoom out. So it is a global level data, and now here you can able to visualize here. So highest anomaly being observed in this part of the region. So red indicates the highest anomaly and the yellow indicates the least anomaly. So based on our styling, color styling, starting from yellow to red, the highest anomaly being indicated in red color and the lowest anomaly is indicated in yellow. So you can able to visualize there is a significant anomaly being observed in this part of the region and also towards this part of the region. So this is the Antarctica. So in Antarctica you can able to observe the significant part of the region. You can visualize there is a high anomaly, and similarly in Greenland you can observe the highest anomaly. So you can able to visualize that. So now to export this data to a Google Drive. So essentially this script is loads the grace data and filtered by day and calculates the mean and clip to a specific region, and then visualize and export our result. So now to export to a Google Drive, so all you have to do is to go to the navigate to this option called task and click this option called there is an unsubmitted task and click this option called run. So once you did that, a window pops up saying initiate image export. So task is of grace and we can export to our drive and in GeoTIFF file format. So once you did that, we're going to click this option called run to export to our Google Drive. So now I can able to visualize the task section. I have previously been exported to my Google Drive. So it took around 39 minutes to export to my Google Drive. So in this way you can download and visualize our Grace Tellus monthly mastered land dataset using Earth Engine. So this data essentially provides us as a monthly gravitational anomaly. So in this video I have shown you how to download and visualize a Grace Tellus monthly mastered land dataset using our Earth Engine. So thanks for watching, and please subscribe to our channel and give us a like.